Okay, so today we're going to talk about conduction, convection, and radiation. And they all deal with thermal energy. Thermal energy is heat. So anytime you see thermal, it means the word heat. Thermal, heat, thermal, heat. I want to make sure you know that. Now, conduction, convection, and radiation, like I said, are three different types of heat transfers. It could be by direct touch. One of them is direct touch. One is a liquid and gas. And one is by electromagnetic waves. So on this first slide, it says conduction, convection, radiation, essential questions. What methods can be used to demonstrate thermal energy transfers? And what are conduction, convection, and radiation, including examples? Those two essential questions you should be able to know without looking it up by the end of this video. So it says on the left, reflect on the essential questions before you dive in. Number one, if you were quizzed today, which questions would you already know the answers to already? In this box, you're going to put question one, which is here. So if you're quizzed today, would you know question one? Question two, or none? So you can write one, two, or none that you would know. Number two says, which questions would you need to learn more about to be able to answer confidently without looking it up? Would you need to know more about one, two, or both? You're going to write one, two, or both here. Now, conduction, convection, radiation, we're going to start with thermal energy. Thermal means heat. So it's energy that is generated by a source and measured by heat. It's generated. Generated means it's made by a source. Generated is made. So energy that is made by a source and measured by heat. It can be transferred. Types of examples are kinetic and chemical. Kinetic. Kinetic is motion. We learned about that. So the faster you go, it generates heat. Chemical. Chemicals generate heat to be able to do their chemical change. The sun generates heat. An oven generates heat. There's many things around us that generate heat. So it says here, what is thermal energy? Well, thermal energy is heat energy. Heat, you're going to write heat here. Then it says, what is an example of a source of thermal energy? Well, it's asking you what item that you know of makes heat. So you're going to come up one item, any item that makes heat right here. Okay? So now we're starting with conduction. Conduction is a movement of heat or electricity through matter. We can't see matter, but it's there. So a matter could be, well, we can't see it. It's a solid, a liquid, or a gas. So the movement of heat or electricity through a solid, a liquid, or gas. But for conduction, conduction means direct touch. So if I were to take a metal pot and a metal spoon, and that pot was hot, it would make that metal spoon hot. And that's what conduction is. It's making one item that's really hot and transferring it by direct touch to the other item and making that other item super hot. So a metal is a great conductor. So, and then solids are, but not all solids. Solids are great conductors, but not all. Metals are the best. If you touch a metal to a metal, that metal is going to turn the other metal hot as well. So it says, what is conduction? Here, I want you to write the movement of heat or electricity through matter. And I want you to add this in, by direct touch. Then it says, how does the image to the left show conduction? Well, this is a metal cup to, I would say, a metal spoon. When that metal cup is hot, you see the steam here. Well, you have the cup and you have the spoon touching that cup. That hotness from that cup is now turning that spoon hot. You see the red here? That means it's turning it hot. So how does the image to the left show conduction? Well, it's transferring the heat. The cup is touching the spoon, transferring the heat from the cup to the spoon. That is what I want you to write there. It says, here are three ways thermal energy can be transferred. Remember, thermal is heat. It's conduction, convection, and radiation. So looking at this image right here, percent. you're going to see all three. So, based on the image to the right, how does conduction transfer heat? Well, conduction transfers heat is the metal burning here, right? It heated up the pot. So here's where the conduction happens. The pot is hot. You touch the handle. You touching that handle is what transferred that direct heat. That is conduction. So how does conduction transfer heat? It goes from one item to another by direct touch. That's what you're putting here. Goes from one hot item to another by direct touch is what you're putting right there. This is based on the image on the right. How does radiation transfer heat? Well, radiation coming from, see here where the burners are hot? See the electromagnetic waves? I told you were the waves. That is your radiation. So it's the heat coming off of the bottom and radiating top to warm up everything above it. Then based on the image to the right, how does convection transfer heat? Well, right here is where your convection is. So you have the water, it's a liquid or a gas. That's what convection is. So when you have that boiling pot of water and you feel on top, you feel that steam that's from the liquid in the pot, that is convection. It heats you up. So it's a heated liquid or gas touching a liquid or a gas. So how does convection transfer heat? It's a liquid, it's a heated liquid or gas that we touch a liquid or gas, okay? So here's that picture again. The law, learn about the law of conservation of energy. That energy cannot be created nor destroyed, only transferred from one type of energy to another. So, like it says here, the law of conservation of energy tells us that the energy can neither be created nor destroyed. With that knowledge and your understanding now of conduction, convection, and radiation, I want you to predict what happens to the air above a stove. So if the stove is on, what happens to the air above the stove? Does it get cold or does it get warm? Number two, because it's heated up right here. So it's asking the air above the stove, the air right here. If you were to put your hand above a stove that's turned on, will it be cold or warm? That's what you're going to write for number one. Number two, the person's hand, they're touching a hot metal pot. Is it going to get warm or cold? And number three, the burner on the stove. If you were to put your hand on that burner, it's going to be hot or cold. Okay? So convection is a transfer of thermal energy through a fluid. Thermal is heat again. So the transfer of thermal energy through a fluid, which is a gas or a liquid. Due to differences in density, let me do that. Due to differences in density, it means density is how thick something is. So it's not a solid. Gases and liquids have different density, and that's why they're gases or liquids. And then hot fluid rises while cold fluid sinks. So hot fluid goes up and the cold sinks to the bottom. That's why we feel the heat up here. So what is convection? Convection is the transfer of thermal energy through a fluid, a gas, or a liquid is what you're going to write here. Then it says to the left, how does the image show convection? It shows hot fluid rises while cold fluid sinks. Hot rises, cold sinks. That's what you're going to write here. Hot fluid rises and cold sinks. So radiation. Radiation we learned was transferred through UVA and UVB rays, ultraviolet rays, and it's done through electromagnetic waves. So it's energy transmitted in a waves or a stream of particles. Travels through space and other types of matter. So radiation, you're going to write this. Energy transmitted in waves or a stream of particles. I also want you to include here, and those little parentheses things, I want you to include electromagnetic waves, UVA, and UVB. Okay? Now, then it says, how does the image show radiation? Well, the sun these are electromagnetic waves are hitting the earth and warming up the earth. That is what you're going to write here. This one, it says you will use each piece below once. Click and drag each piece to its correct spot. Build a pyramid that includes the definition for each vocab word. So you're going to take this, click it, and drag it. It says hot fluid sinks while hot fluid rises while cold fluid sinks. You're going to say, is that conduction, convection, or radiation? The same thing with this one, the movement of heat of electricity through matter. And I'll click and drag it to conduction, convection, or radiation. Then last one, energy transmitted in waves or a stream of particles. You're going to move that to conduction, convection, or radiation. Then we're going this. You got to think about this. You got to type your answer in this box right here. Give an example of how radiation, Give an example of how radiation is transformed into other forms of energy. So what's an example of how radiation could turn into either thermal energy, conduction energy, conduction energy, convection energy. How is it transformed to conduction or convection? I think a lot when I think of the sun and radiation, I think of the convection currents. What I said is that heat, that radiation comes down, it hits that water and stays back up like in the water cycle. And that will start convection because convection is a liquid or gas. So that is something you can write there. This one, examples of conduction direct contact is touching a metal spoon in a cup of hot liquid, putting a heating pad on your back, feeling the heat from a hot poker in a fireplace. The poker is at this long thing. It has two things like this. And you touch it in to move the coals around or the wood around in a fireplace. It's not touching direct the fire and turning warm. Or placing a hand on top of a basket of hot rolls. And then it says here, list one more example of conduction. I want you to think of something that is hot, and when you touch it, turns hot to you. Or when something touches it, gets hot as well. Now, examples of convection, which I said is hot rising, cold sinking. Macaroni rising and falling in a pot of boiling water. A lava lamp rising and sinking. Hot magma rising in the mantle, cold sinking. Hot air rising in the atmosphere, cold sinking. Hot water rising in the oceans, cold sinking. That is what I was talking about for an example of radiation when it transfers from one energy to another on slide 10. So using your knowledge of convection, why is the attic of a house normally the hottest? Think about this. We talked about hot rising and cold sinking. That is what you're going to write here. So the bottom floor is always going to be the coldest, and the top floor is always going to be the warmest because hot air rises, cold air sinks. And that's what you're going to be putting here. So conduction, convection, and radiation. Examples of radiation, waves or particles of energy. This is examples of radiation. Laying out in the sun at the beach or at the pool, holding your hand over a burning match without touching it. Feeling the warmth of a bonfire, holding your hands over a light bulb, and you feel that heat. You're not actually touching the light bulb. Your hand is, if you were touching the light bulb, that would be conduction. But if you hold your hand over and you feel that heat, that is radiation. So once heat is transmitted by direct contact, it is no longer radiation. What does it turn into? So it's saying once you touch something, it's no longer radiation. Does that turn into conduction or convection, direct touch? And that's what you're going to write here, conduction or convection. Remember, direct touch. I'm hoping you put conduction. All right, 14. This one you are going to do on your own. Read the description on the left column. Choose the word that best matches the description. Click on the answer choice and drag it off to the side. If you are correct, you will reveal a check mark. If you are incorrect, you'll reveal an X and try it again. So what you're going to do is feeling the warmth of a bonfire. You're going to take this, you're going to drag it to the side. Oh man, that's wrong. Let me put it back. Then you're going to do convection. Oh man, that's wrong. Put it back. You got to keep doing it until you get, it looks like all check marks all the way through. You're going to click and drag like that, okay? So each of these sayings is either conduction, convection, or radiation, okay? This one, think about it. When electricity isn't available, explain how the location and design of a house can help control temperature using conduction, convection, or radiation. It's saying that where you build your house and how you design it would help control the temperature. What do you need to make sure so you don't get your house too hot and too cold when there's no electricity when you're designing your house? Think of the things about radiation, how it comes down and heats up. Conduction, direct touch, heats up. What things can you do to make those things heat up your house or cool it down? Or convection, hot air rises, cold air sinks. You're going to type what you think here. 16, study each scenario on the right. Identify each one as conduction, convection, or radiation. And then provide a short description that describes the heat transfer. So this one, I'm going to do the first one with you. Describe the heat transfer in the picture on the right. Well, this is conduction because metal touching eggs, conduction, direct touch. So you're going to write conduction. Then you're going to write, okay, here's how the heat transferred. It's transferred from the metal pan to the eggs, and it's heating up the eggs. Then it says, when you are finished, come up with 2 other examples on your own down here. You're going to come up with 2 examples. So you're going to write things like this down here, and you write what type of energy, what type of heat transfer it is right here, okay? And the description of what's going on. So each one of these, you're only going to use conduction, convection, or radiation once. So one is conduction. That means these 2 are either convection or radiation. And you're going to describe the type of heat transfer, okay? 17 says define conduction, convection, or radiation and give examples. So I want you to define all 3 words and then give an example of each. What example of each? And then 18 says, which essential questions do you still need help to understand? You're going to go back to this slide and say, I still need help with question 1, question 2, both, or none.